Right, so we now know what the derivatives of sine and cos are. So let's just have a look at some questions now which contain those trig functions. So the first one, y equals sine 3x. Now what we've got here is an embedded function. We tend to write that as that, but you could, if it helps you, and if you were to type sine into your calculator, remember that what automatically happens is it opens a bracket. So everything that comes after that is embedded inside that sine function. So what we've got there is a chain rule. Okay? There's our embedded function. So because we haven't done this for a few weeks now, let's go back to scratch and put the u in there. So it's a chain rule. So we let u equal the embedded function, which is 3x. We can then differentiate that with respect to x and get 3. Now our function, the y function, is now sine of u, which we can differentiate with respect to u to get cos of u, because when you differentiate sine you get cos. Then the chain rule part of that, dy dx is dy du times du dx. Once we finish differentiating there, I can replace u back with what it was. So that is cos of 3x. So dy du is cos 3x times du dx, which is times 3. Now again, you need to be careful here. There's a temptation to say, well, 3 3s are 9, but remember that that is embedded within that cos function. So that becomes 3 cos 3x. Now the chain rule is one that I encouraged you when we were practicing this a few weeks back to take a shortcut on, because it crops up that you have to often use a chain rule inside one of the other differentiating rules. So just to remind you what we would do, cover up your hidden function, your embedded function. So we're going to differentiate dy d finger. So dy d finger is going to be cos finger, which is going to be cos 3x. So cos 3x multiplied by the differential of what you've covered up. So you differentiate 3x, you get 3. So you just get down to that line straight away without any of the other work. It's really important that you can manage to do the chain rule just by inspection. B. Y equals cos cubed x. Now this is another one, a bit like the one above, where being lazy mathematicians, we write it in a way which sometimes you forget what that actually means. Okay? Cos 3x means cos x all cubed. So you're working out the cos function and then cubing it. Once it's written like that, it's easy. It's not easy, it's clearer what you need to do. It's an embedded function. We've got another chain rule. Okay, so we're going to chain rule it. But this time we'll do it all in one go. Cover up the embedded function. So it's the cos x that's tucked inside this cube. Differentiate your finger. 3 finger squared. 3 finger squared multiplied by the differential of what you'd covered up, and you covered up a cos, and you differentiate cos, you get minus sine of x. So we can tidy this up a little bit now. The 3, the whole thing's going to be negative because it's a product, so it's going to be minus 3 sine x, and then we can write that cos x all squared in the same way we've written it there. If you write it like that, it's not incorrect and you wouldn't lose any marks. It means the same thing. It's just we tend to write it like that. So when you differentiate cos cubed x, you get minus 3 sine x cos squared x. And then C, so I'll write down here and then move the page up. So sine squared 2x minus 4. Okay, let's write that with the squared like that. Okay, so it's sine, so we got 2x minus 4, which is a function, tucked inside a sine function, which is tucked inside a squared function. So we've got a chain rule inside a chain rule inside the chain rule. So we've got a double chain rule going on here. So, chain rule. dy dx. So, first thing we've got is finger squared. So when we differentiate finger squared, we get 2 finger. 2 sine 2x minus 4. Then we differentiate what we covered up. What we covered up was sine a finger. So when we differentiate sine a finger, we get cos a finger, which is cos of 2x minus 4. Then we have to multiply that by the differential of what we'd covered up, which is 2x minus 4. So when we differentiate 2x minus 4, we get 2. Okay, do that again. The first layer of embedded function, or the highest layer, is when whatever uncovered up is being squared. So when we differentiate that, we get 2 times whatever I've covered up to the power of 1. So 2 times sine 2x minus 4 to the power of 1. Let's put that in so we're clear. I have to multiply that up by the differential of whatever I've covered up. Whatever I've covered up is a sine function. When I differentiate the sine function, I get cos of whatever I've covered up. So cos of whatever I've covered up is there. And I have to multiply that by the differential of what I'd covered up. So I differentiate that, I get 2. So there, that becomes 2 times 2 is 4 sine 2x minus 4 cos 2x minus 4. Now, that's not incorrect, but it can be simplified further using trig identities that you've been practicing. So you should be spotting that I've got a multiple of 2 times sine times cos, and I know that sine 2 of an angle is the same as 2 sine angle cos angle. So dy dx I can write as 2 times 2 sine 2x minus 4 cos 2x minus 4, and that I can write as sine 2x minus 4. Which is 2 sine 4x minus 8. So when you are working with expressions or functions that have got trig function in them, you have to also be watching to see if they can be simplified further using those trig functions.